Particles of matter. How small are these particles of matter? How small are these particles of matter? So there is an evidence. There is an evidence or there is an activity to show that how small are these particles of matter. So here we can take one more activity. One more activity. We can explain this by taking an evidence with the help of activity. It's nothing but I can take a beaker. Take a beaker and add 100 ml of water. What is this, children? Take a beaker containing 100 ml of water and add 2 or 3 crystals of potassium permanganate. But it's 2 or 3 is very little amount, so we'll take 1 scoop of potassium permanganate in it. What we are taking? Potassium permanganate. What is the formula of potassium permanganate? What is the formula of potassium permanganate?
Ma'am, KMNO4.
Very good. Potassium permanganate is KMNO4. What is the color of potassium permanganate, children? Pink or magenta color. Okay, nice pink or magenta color. Okay. So we have taken a beaker containing 100 ml of water, 1 spoon of potassium permanganate in it. Okay, we completely dissolve the solution by using glass rod. We'll use glass rod to dissolve the solution, children. So again, take one more beaker. Take one more beaker containing again 100 ml of water. 100 ml of water. And transfer roughly like 10 ml from this solution. Understood? Just transfer approximately 10 ml of solution to the second beaker and dissolve it with the help of glass rod again. Okay. Repeat the experiment for 5 to 8 times. Repeat the experiment. Like again, take one more beaker containing 100 ml of water in it, and take again transfer from this again 10 ml of solution from this to the other beaker containing 100 ml of water. And again, stir it with the help of glass rod. And again, repeat the same experiment for how many times, children? 5 to 8 times. In general, what do you observe? What do you observe by doing this? Here we can say that here the beaker containing 100 ml of water with 1 spoon of potassium permanganate in it, we can see that dark color concentrated solution of KMNO4. When we have taken 10 ml from this, or when we transfer 10 ml from this to the other beaker containing 100 ml of water, so what happened? We can see that light fading of the solution. Am I right? The color gradually fades or decreases. Okay, till 5 to 8 times. If you repeat the activity for 5 to 8 times, we can see that here the last beaker, we consider as the 8th beaker is the last beaker. So what happened? Though the sample is light, we can see the light color of potassium permanganate present in it. Very light, very faded color potassium permanganate solution in the last beaker. With this activity, what is the evidence we can say that the particles are very, 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 very small. They break by themselves and they transfer from one beaker to the other beaker till the 8th beaker. We can say by this activity, we can say that the particles are very small. Very small. They are very tiny. Understood? Only here, this is 100 ml of solution. From this only 10 ml you have taken the sample into 100 ml of water. So here the color fades a bit when compared to this. Here gradually the color fades. By seeing the color, what we'll observe? The particles, though we have taken very minute amount, very little amount of the solution, we can see that the particles are present in it. The particles are present in it. Till the 8th beaker. Till the 8th beaker, we can see that light gradual fading of the solution in it. Understood, children? So this is one more activity to show you that the particles are very, very small. The particles are very, very small. Understood? So here conclusion, what we conclude that there are millions of tiny particles in just one crystal of potassium permanganate, which keeps on dividing themselves into smaller and smaller particles. What is the main conclusion for this activity, children? We conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keeps on dividing themselves into smaller and smaller particles. That means we can say that the particles of matter are very small. They are small beyond our imagination. Understood, children? Understood? The same activity can be done with Dettol also. This is the same activity we can do with the Dettol also with the help of odor. Okay, so we can feel that we can feel a strong odor of Dettol, antiseptic lotion. Antiseptic solution, Dettol. Okay, same activity we can do with the help of sample called Dettol. Same like beaker, we are taking like first beaker to beaker. How many beakers we are taking? Like 6 to 8. Last beaker. Same way we are diluting 10 ml from first beaker to the second beaker. Okay, containing 100 ml of water. But here, first activity we can see the color change easily. But this the same activity only. But here we are using the sample with the sample is nothing but Dettol with the help of odor. Okay, because Dettol gives a strong odor, so we can feel from the first beaker containing few ml of Dettol in 100 ml of water, it is more stronger when compared to the 8th beaker. Why? Because of dilutions. We can't say that 8th beaker doesn't contain Dettol. Because particles are divide themselves. Particles divide themselves into smaller particles and they can transfer from first beaker to the 8th beaker. 8th beaker. So how many, though you are diluting the samples, we can feel. Like if we can't say that infinity samples we can take, limited samples we can say that how much the particles can be broken down into simpler particles so that they can transfer. Okay. So what is the main theme of this evidence, children? The main theme of this activity? The particles are very small. The particles are very small. So I have shown you the activity with the help of KMNO4. KMNO4 is nothing but potassium permanganate. Please note down the colors. Please note down the colors. That's why I have shown you the video. So that you can easily remember the color. Okay, potassium permanganate, it is pink or magenta. Okay, so when the dilutions are going from first beaker to the last beaker, we can see the dilutions fading of colors from the first one and the last one. The same way we can also do with the what is the other sample we can take and do the same activity, children? The other one is Dettol. The other one is Dettol. But with the help of odor, that is also a physical property. Here color is a physical property and odor is also a physical property. Here in this chapter we are only dealing with physical properties. We are not going to touch any chemical properties of matter or substance.